Welcome to this video. In the previous video, I talked about language. Now, in this video, I will talk about finite state machine and how I can design a finite state machine for a particular language. So, let us first define what is a finite state machine. So, a finite state machine a finite state machine is nothing but a mathematical model to solve some problem related to pattern matching. So it's a mathematical model to solve a problem related to pattern matching. Fine. So it is nothing but a mathematical model for solving some problem. Now, if we try to define FSM mathematically, then the mathematical definition of finite state machine is a finite state machine. It is a multi-set. It is a multi-set M which is containing something called Q. I will define Q later on, but M is Q, sigma, then del, then what we have F, and one more thing is required is Q0. So, finite state machine is nothing but a multi-set M which is containing Q, sigma. Sigma already we know it is an alphabet. Okay. So rest of the things we are not aware. What is this Q? What is this del? What is F? And what is Q0? So that we are going to discuss. So let's discuss it. Here the Q is nothing but set of state. So Q is set of states. States here you can say state is a unit which actually remembers or process something, right? So F is a set of states, and states are nothing but some memory unit and some processing unit which process something, some computation. Then we have the sigma. The sigma is nothing but the alphabet which I already defined. So alphabet is nothing but set of symbols. So, or we can say set of symbols. Then we have the del. So del is normally called transition function. And mathematically, what is transition function? It is basically a function from set Q to sigma which gives you some q, right? So it is a function f from set q to set sigma, and it is giving you something in q. In other way around, what I can say, this is not f, this is del. So del of q sigma is giving you something from q, right? So that is the meaning of del. Fine. Then what we have, the final states. So it is set of final states, and obviously this is not other set, it is a subset of q. So this set of final state, there may be more than one final states. So it is a set of final state, and obviously it is subset of this q. It's not other set, it is a part of this q. Next one is q0, and this stands for start state. So there is only one start state. Start state means from where your computations start. At which particular point you will start the computation, from which particular point. So this is what the meaning of each and every symbol. Now there is some pictorial representation for something. There are some pictorial representations for states, and final state and the start state, and the transition also. So let's see that pictorial representation. If we want to represent a state, then any state can be represented by a circle. So a circle, it actually represents a state. Now, a circle with an arrow sign, okay, this is called start state. Okay. Now a circle, inside a circle, this is basically represented for final state. Okay. So this is what representation done for the states. Now, if we say there is a transition from state Qi with the input of symbol A, and it is going to state Qj, then I can represent this whole thing like this. This is a state Qi, and this is a state Qj, and there is a transition by having the symbol A. So if the current state is Qi, and the input to the state Qi is symbol A, then the next state is Qj. That is the meaning of transition. Okay, so that is the meaning of transition. So if the current state is Qi and the input which the machine or this model is reading is A, then the next state will be Qj. Okay. Now, let us see how this model works, how this machine works, finite state machine works. Finite state machine is having a tape. This is called tape, and this tape is divided into some of the cells. So this one is called cell. There is a finite control, and basically let's talk a little bit about tape first. This tape is semi infinite. So what do you mean by semi-infinite? This tape has a left end, but there is no right end. So this is the left end, but there is no right end. No end. Okay? So there is no right end, but there is a left end. Okay. And there is a finite control, and there is one thing which is called read head. Okay. Now, fine. So there is a read head, and what this read head? It can read a symbol from a cell. Okay. So this is a pictorial representation of this machine, how this machine works. So what is the working style? This is what the configuration is. What is the working style? So working style is like this. First point, that is the working style of this machine. The input is loaded onto the tape. That means okay, the input is loaded onto the tape. That means the cells are containing symbols. Cells are containing symbols. Each cell can contain a maximum of one symbol. Okay, so the first step is whatever input we want to process, that input will be stored or loaded onto the tape. So if the input is suppose A, B, C, then the tape is looking like this. The first cell, the leftmost cell, is containing A, then we have B, then we have C, and we can assume that if the input is ABC, there is only three symbol. Then after that, either the cells are blank, either we consider it as a blank cell, or we consider there is a dollar kind of thing. Dollar. Sometimes some book refer it as a pound sign also, or the hash. Okay. So either it is a dollar, you can think that all the input is either ending with a dollar, or sometimes some books refer it as a hash symbol also, pound sign also. So this is how the tape look like. Next one is the finite control. The finite control is in a state Q0. So the finite control is always starting with the state Q0. It is always in the state Q0. That is the initial configuration. The third point is the read head always points to leftmost cell. So the read head is placed on the leftmost cell. Okay. Now let's talk about the behavior of the read head first. So that is the fourth point. The read head, the head can read one symbol at a time and move forward to one cell at a time. Okay, so what we have, suppose this is a tape. Here we have A, here we have B, here we have C, suppose here we have the dollar, and initially the head is obviously pointing to the leftmost cell, but after reading this symbol A, the head will always move one cell forward and pointing to the cell containing the B. After reading this B, the cell again, the head again move to the cell containing the C, and after reading this C, the head again move to the cell which is containing the dollar. So the head must not stop or must not go back. That is the point. So that is for the head. Fifth point, after reading a symbol, the finite control always change the state. So after reading the symbol, the finite control changes the state. Now it is not written here or not mentioned here that always the state will be new. No, it might possible after the changing the state may be same. So the transition go in the same state, that is also possible. Okay. So, and last point, if after reading or after reading dollar or after reading last symbol of input, after reading the last symbol of the input, if the finite control control mm, stops in final state, in that case input is accepted, otherwise the input is rejected, right? So after reading the last symbol, obviously the cursor or the head is pointing to the dollar, right, or the pound sign. So if after reading that if the cell is on pound sign and or the dollar sign, and the state of the finite control is the final state, then we say the input whatever is supplied is accepted, otherwise the input is rejected. Sorry. So this is how the machine actually works. Fine. So let's design a finite state machine for some particular language. And the first problem which I want to supply is like this. Suppose there is a language L which is having AA, AB, BB. Now we need to design a finite state machine for this particular language. Now what is the meaning of designing finite state machine for this particular language? The machine must accept AA, AB, BB, but machine do not accept any other string, right? That is the main point. So if machine is supplied with the input AA, the output will be accepted. But if I am supplying to the machine AAA, it should be rejected. So whatever this language is containing, all the string will be accepted. But if something is not in this language, then the machine should reject it. So that is what the conception about designing the machine. Now, how we will design it? Let us say I have one state, and what this state is processing, it will process A. So it is processing A, right? Or if you analyze this whole strings in the language, you can analyze that either the symbol is starting with the A or it is starting with the B. So there is two chances, either it is starting with the A or it is starting with the B, right? So if you are in this state and if you are getting A or B, you will migrate to another cell, another state. What is the meaning of this state? This state is saying this is obviously the start state. So still it is not seen any particular symbol. So not seen A or B. That is the meaning of this state. And once if you have not seen any A or B and you are seeing A or B, then you migrating to this and you say saw seen A or B. So one of the symbol you have already seen. That is the meaning of this state. Now the next symbol, if you analyze, if it is B, let us say I am defining it like this. I have not seen any A or B, so I have seen A. By having A, you go to the state which say I have already seen A. If you have seen B, then you go to this state and you say I have seen B. Now the strings are either starting with A or it is starting with B. Now the next symbol, if it is A, then both is permittable. That means the next symbol may be either A or B. So the next symbol, if you have seen A, the next permittable symbol is A or B, both. So if you have seen A or B, then you can go to the state and you say you can see seen either AA or you have seen AB, right? But if you have seen B, then it should be noted from this language that the next symbol permittable is only B. So if you have seen A, then that is not permittable. So if you have seen if you have seen B, then you have seen either A or AB or you have seen BB, right? But if you have seen A from this point, if you have seen A, then that is not permittable. So I go to one state which is called dead state, and dead state means you cannot come out of this state, means you say that I am going to reset everything if I am in this state, right? So this one is the final state. Right? This one is the final state because you have already seen either A or AB or BB. Now it might possible that the length of the string is more than 2. Here all the string is having length 2. So if you are getting any other thing after this, means you have seen AA, AB, BB, but then the input is more than this. So if you are getting AB after this point, you go to the dead state and you say no, I am not going to accept it. Okay, so this one is the start state and this one is the final state, right? So that is the meaning of this language. Fine. So let's see how this machine actually works. So machine, let us give the name this to this particular state A, B, C, and this is already given D. Suppose this state is E, or this state is B dash. Okay. So how to write this particular machine in a mathematical way? Here Q, that means set of states. So how many states we have? 1, 2, 3, 4, 5. For that state we are going to write A, B, B dash, C and D. So that is for the Q. Now what is final state? If we want to write final state, what are the final state? There is only one final state which is called C. So final state is C. Sigma is nothing but the symbol permittable in this language, and symbol permittable in this language is A or B. It is A or B. Then we have the start state Q0, which is nothing but the state A. From this point I will start. And what is del? Del I need to write in a very another way around. I need to write it in some tabular form. So let's write it. So if you want to write del, here there is two possibility. Either I will get a or I will get a B, right? And then I have the states A, B, B dash, C and D. So okay. Now if you look at this state A, and if you are getting a A, then you are going to the state B. So this is what the del is. A, by having A, you are going to the state B. By having A, if you are getting B, you are going to B dash state. Now, if this state is, the current state is B, and if you are getting A, you are going to state C. And also if you are getting a B, then also you are going to the state C. B dash, if you are getting B, then you are going to C dash, a C state. But if you are getting if you are getting A, then you are moving to the state D. From the C state, if you are getting A or B, then you are going to the D state. And D state, if you are getting A or B, then you are in state D itself. So this is what the transition function is, how the system will transit. Okay. Now let's see how this machine actually works. So let us say the input symbol is A. So the machine must start with the state A. The starting state of the machine is A and the input is A. So input is A and the starting state of the machine is A. So first the read head will read this A, right? So read head will read this A. So if you read A, then what will happen? You need to go to the state B. Then if you read, after reading, the head should move to the next location, that is on this A, and if you are reading A again, you are moving to the state C, and then the read head should move to the last thing, which is called the dollar. And if you are in the dollar state, means if you are reading the dollar, and what is the symbol, what is the last state? That is C. C is the final state, as C is final. AA is accepted. Okay. So if the C is the final state, the last state is the final state, and your head is on dollar, then you can say this string, this AA, will be accepted. But let us say, what if I have BA as an input? Now BA is obviously not in this language, and this particular model should reject BA. So it's a BA dollar. Initially the head is on B and the head is reading B. Start state is always A. So after reading B, after reading this symbol B, you go to the state B dash. And then if you are reading A, you go to the state D. So after reading this B here, you go to the state B dash, and your reading head will be on this A. Now after reading this A, you go to the state D, and your reading head will be on this dollar. So what is the last state you are getting? When your cursor is on dollar, the last state is D. So as the last state is D, and D is not final state input is rejected, right? So input should be rejected. Getting the idea? So this is how this whole model works. Okay, fine. Let's see one more example that will clear the concept a little bit more. Suppose the language is suppose the language is I must write the language L in this way. It is containing some symbol, some string W belonging to A, B star such that the length of W is greater than equal to 2. So the length of the W is greater than, this is called length. Length of string W. So length of the string should be greater than 2. Okay. So what do you mean by greater than 2? If you try to write it in a set form, then I must write all the something from AB star. So what is AB star? It is epsilon. So here is A comma B star. So the meaning of AB star is 0 length, that is epsilon, A, B, then I have A, B, B, A and B, B, then we have A, B, A, B, A, B, 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 A, B, A, B, 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 A, B, 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 and keep on going. Now, what will be the L? If you analyze L, what is it? What it is said? The length of the W is greater than or equal to 2. So, the length of this is 0. Length of this is 1. Length of this is 1. Okay? So, we must not accept the length whose length is less than 2. We must accept all the strings whose length is greater than or equal to 2. So here the length is 2, we should accept it AA. Here the length is 2, we should accept it AB. Here the length is BA, that is again 2, it is BA. The length is 2, that is BB, it should be accepted. The length is 3, we should accept it AAA. The length is 3, so we should write it in the language AAB. The length is 3 again ABA, and keep on going. So we should, if we try to design the model for this particular language, the language should accept all these things. But if I am getting only A or epsilon or 1 or this B, then this should be rejected. Rest of the things should be accepted. So, how to design the model for this one, for this language? Okay. So, as usual, I have the first state and not seen A or B. So if I am starting my machine, I didn't see anything, so that is what I have not seen AB, right? Now if I am getting A, right, or possibly if I am getting a B, then I am moving to the state, another state. Okay, and in other way around, if you want to write it in a very simplistic form, you say here this state actually represents W, length of W is equal to 0. So if you have not seen any A or any B, then you must the length what we have seen is 0. This particular thing is saying length of W is equal to 1. So if you have seen either a single A or single B, the length what you have seen is 1. Now this particular state representing length of the W is equal to 2, right? So we should accept all and what we can say it is greater than equal to 2. So if anything we have seen whose length is greater than equal to 2, then we should accept. And if the length is 0 or length is 1, we should reject. So if we have seen a length of 0 and then we have getting A, obviously the length become 1. So we are moving to the state length of 1. But here again if we see A or B, then the length become what? 2, because 1 is this side and 1 is this side. So that totally it is 2. Now after that 2, if I have seen A or B, the length is obviously greater than equal to 2, right? So after this there is no we should not write like length 3 or length 4, because if we got something greater than 2, we should accept. So this is the simple machine which will reject everything whose length is less than 2, and it will accept everything whose length is greater than 2. So let's see how it works. Suppose the input is $. So let's give the name A, B and C. So first of all, okay, let's see how this actually works. So the input is A and B, and initially the read head is pointing to the leftmost symbol, leftmost cell, that is A, and the starting state is A. This is the start state. So what we will do, from A I am reading A, and then I am moving to the state B, and this read head will move to this location. So what is the last? Here the read head is reading $. So what is the last state we are getting is B. So since B is non-final state, B is non-final state, that is why the input is rejected by this model, right? Let us say, let us test it for another input. Suppose I am going to read A, B, A, $. Let us see whether this is accepted or not. So the read head is on this A and the starting symbol is A. We are reading this A. So from A, if I am reading A, I am going to the symbol B, state B. Then from this, after reading this A, the read head will move to this location, and which is reading the B. So if state is B and I am reading the B symbol, then I am going to state C. And then the read head move to this particular symbol. Here I am reading A again, and if you read A, you come back to this state, which is the C state itself, and then this will move to the $. So now the read head is on $. So what is the last state? The last state here is the C. So if the last state is C, C is final state, so input is accepted. Right? So the input is accepted. Why? Because here, if you consider what is the length of this particular input, the length of this input is equal to 3, and we should accept all the string whose length is greater than 2. So it should be accepted. Let us think about some other language. The language here is L equal to set of all strings from 0, 1 star, where the length of W is less than or equal to 2. So length of W is less than equal to 2. So let's first calculate what is 0, 1 whole star, and then we will see what are the strings possible in the language L. So if you consider the length, if you consider the 0 or 1 star, you will get epsilon whose length is 0. 0, its length is 1, 1 length is 1. The length means number of symbol available in that particular string. So in this particular string the length is 1 because only 0 is available, 1 symbol is available. It is 0, 0, 0, 1, 1, 0, 1, 1. All these things is having length 2. Then we have 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1, 1, and then keep on going. Now according to this language, we should accept those things whose length is less than 2. So the length, all these things, the length is 3, and then we have length of 4, length of 5, length of 6, and so on. So what should be in the L? Length of 0, that will be accepted because that is equal to 2. Length of 1 will be accepted, length of 2 will be accepted, and rest of the things are rejected because the length is exceeding 2. So we should accept these things only and we should reject others. So let's design the model for this particular language. So here again the terminology which I am using is length of this is equal to 0. So length is 0. Here we say length of this is obviously equal to 1. The length of W is obviously equal to 2, and length of W is greater than 2. Okay. So I should accept everything having the length 0, having the length 1, and having the length 2. But we should reject everything whose length is greater than 2. So from this, if we get A, that means length 0 and I am getting 1 symbol, the length become 1. Even if I get B, sorry, not AB, here if I get a 0 or 1, the length become 1. If I am getting again 0 or 1, the length become 2. But if I am getting again 0 or 1, the length become more than 2. And if from more than 2, if you are getting something 0 or 1, then still the length is more than 2, right? So this will be rejected. Rest of the things we are gonna accept, right? So let's see how this machine is working. This is A, this is B, this is state C, this is state D. So let's see, if I supply 0, 1 as an input, then how this machine behaves. So as the state is A, and then the read head will be on 0, so I will get to the state B, and the read head will move to this 1, and then if I read a 1 from the state B, I go to the state C, and then the read head move to the dollar. So if the reading head is moving to the dollar, what is the last state? The last state is C. So as C is the final state, how we determine it's a final state? It is written in double circle. So if it is a final state, input is accepted. And it is quite obvious because the length of this 0, 1 is 2, and we should accept all the things less than equal to 2. So this length will be accepted. Let's see whether the machine is accepting or rejecting the length having 3. So 0, 0, 1. Let us say the input is 0, 0, 1, and let's see whether this model is accepting or not. So model is starting with the state A. It is getting a symbol 0. It go to the state B. Then it is again getting a symbol. When in the start, the machine is in the start state A. It is reading this symbol because this is the leftmost symbol. Read head is here. After reading this A, it go to the state B, and read head move to this state, this particular symbol. So B, here you are reading this 0, you go to the C state. Now you are reading this 1. So this reading 1 from C, if you are reading 0 or 1, you are going to the state D, and then this will move to the dollar. So read head is on dollar. So what is the last state? Last state is D, and as D is non-final state, then so input is rejected. Okay, fine. So this is how this automata is designed, right? In this video, we have seen some of the finite state machines for some language. In the next video, we will continue with this, and we will see some more example. Thank you for watching this video.